Let's kick things off by discussing monomials. A monomial is a number, 1, 2, 3, 4, 5, a variable, a, b, c, x, y, z, or a product of a number and one or more variables in which the exponents are all whole numbers. Now this last part, a product of a number and one or more variables. So these three terms would be examples of that. Negative 2x, our number variable, 5xy squared, our number and multiple variables, similar to 7x to the fourth, y to the ninth. And in all three of these different terms, the exponents are whole numbers. 9, 4, 7 to a power of 1 is 7. 5 to the power of 1, x to a power of 1, y to a power of 2. Negative 2 to a power of 1, x to a power of 1. When the exponent is not shown, that means it's to a power of 1. It's just itself. An exponent that's a fraction would be a radical. So we won't be dealing with those terms. If you'd like to discuss exponents that are fractions, check out our radicals chapters. But let's now dive deeper into what the exponent is. The exponent, which in this case is b, is the number or variable placed at the upper right corner of the base, which here is x. So you have your number or variable that is being raised to a power, or to an exponent b, and then the number in front of it that you're multiplying it times is the coefficient. So let's dive deeper into this. The exponent b represents the number of times you would multiply the base, x, times itself. So you multiply the base times itself, b number of times, and then you take that and you multiply it times the coefficient a. So what would this look like with a few numbers involved? Let's say our base was the variable x, our coefficient is the number 2, and our exponent is 3. That means you're going to multiply the base x times itself 3 times, x times x times x, and then you multiply that times 2 times 2. So 2x cubed expanded is equal to 2 times x times x times x. If the base is a number, 7, you multiply 7 times itself 3 times, 7 times 7 times 7, and you take that product and multiply it times the coefficient 2, and that would have a total value of 686. But this is just an example of how the exponent relates to our base and how those relate to our coefficient. Let's now take a look at a different power, the power of 1. Any base to a power of 1 is equal to itself. 3 multiplied once is just 3. Right? 3 to a power of 2 would be 3 times 3. There'd be 2 of them. So if the exponent's just 1, it's just the base. 3 to a power of 1 is equal to 3. 5x to a power of 1 is equal to 5x. In this case, this 1 is only being applied to the x. Here, 5x to the 1 is equal to 5x. In this case, the 1 is being applied to both. We'll talk a little bit more about this in a second, how the exponent outside of the parentheses relates to each term inside of the parentheses. But let's take a look at the power of 0. Any base to a power of 0 is equal to positive 1. Apply the exponent to the number immediately to the left of it, or to the term inside of a pair of parentheses. So for example, if you just have a number being raised to a power of 0, that's equal to 1. The 0 is immediately to the right of it. And in this example, since this entire term, this monomial, is inside a pair of parentheses, this power of 0 is applied to the entire thing. So it's essentially the same as this. 5 to a power of 0. This is like x to a power of 0. It's just a singular term being applied to this exponent, just like this. So it's also equal to 1. The power of 1, the number remains itself. The power of 0, the term is equal to 1. Now, if you have a negative and the negative is not inside the pair of parentheses, the exponent is only applied to the term. So negative x to a power of 0 is equal to negative times whatever the result of x to the 0 is, which is 1. So that would give us negative 1. Again, the exponent is only applied to the number immediately to the left of it if there's no parentheses. So here, the 0 applies to the x. So this becomes 1. So you get 5 times 1, which is equal to 5. So throughout this chapter, you want to be very careful as to what term or which terms the exponent that you see is being applied to. So be very careful as you are multiplying variables, simplifying expressions, and so forth. Let's now take a look at another example involving the negative sign. The negative sign in front of the base is only affected by the exponent if it is inside a pair of parentheses with the base. If not, the exponent only affects the base itself. So in this example here, we have negative 2 to a power of 4. The negative is a part of the term 2, so the 4 applies to this entire thing. So you multiply this entire thing times itself 4 times. So we get negative 2 times negative 2, that's twice, times negative 2, 3 times negative 2, that's 4. And that would equal positive 16. If the negative is not inside a pair of parentheses with the number 2, then this exponent 4 only applies to the 2. So the negative stays on the outside as you do 2 to the 4th, 2, 2, 2, and 2. So negative 1 times 16 would give us negative 16. So pay close attention to the negative signs, the parentheses throughout these expressions. It drastically affects the values of these expressions and terms. Let's now do a few practice questions. Evaluate each for x is equal to 5. Question number 1, 3x to the 4th. Question number 2, negative 4x to the 3rd. Question number 3, negative 6x squared. And question number 4, negative 3x squared y to the 0. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given the monomial 3x to the 4th. Here we see our exponent is the number 4, and it's being applied to the base of x. So since we're evaluating for x is equal to 5, step 1, plug 5 in for x. So where we see x, we plug in 5. So we get 3 times 5 to the 4th. Step 2, replace the exponent 4 by multiplying 5 a total of 4 times. So that's equal to this, 5 times 5 times 5 times 5. And we're multiplying that times the coefficient of 3, which would give us 1,875. Question number 2. We were given the monomial negative 4x to the 3rd. So we want to plug in step 1, 5 for x. So that gives us negative 4 times 5 to the 3rd. Step 2, we want to replace the exponent 3 by multiplying 5, the base, a total of 3 times. So x cubed, when x is equal to 5, is equal to 5 cubed, which is 5 times 5 times 5. Multiply that times the coefficient of negative 4, and that would give you negative 500. Question number 3. We are given the monomial negative 6x squared. In this case, we have negative 6x enclosed in a pair of parentheses. That means step 1, we still plug in 5 for x. That gives us negative 6 times 5. And since negative 6x is inside the pair of parentheses, this negative 30 is what you're multiplying a total of 2 times, step 2. So you get negative 30 times negative 30, which gives you an answer of 900. And question number 4, we are given the term negative 3x squared y to a power of 0. Step 1, plug 5 in for x. That gives us negative 3 times 5 squared. And step 2, we want to replace y to the 0 with positive 1. So that gives us this. Negative 3, 5 squared times 1. And 5 squared means that we're multiplying 5 a total of 2 times. So this equals negative 3 times 5 times 5 times 1, which equals negative 75. So those are a few examples about how you would evaluate the value of a term that has multiple variables if you're plugging in a value for one or some of those variables, and how the negative sign is affected by the presence of parentheses. Now, before we move on to discuss the product rule, let's discuss negative exponents. A negative exponent in the numerator becomes positive in the denominator, and a negative exponent in the denominator becomes positive in the numerator. So this example, 6 to a power of negative 2, this is technically in the numerator. It's being divided by 1. So to make this exponent positive, you switch this term and put it in the denominator. That's how we go from negative 2 to positive 2. So 6 to a power of negative 2 is equal to 1 over 6 squared, which is equal to 1 over 36. Let's say you had 2 times x to a power of negative 3. This exponent is only being applied to the x, since this term is not inside a pair of parentheses. So this 2 remains in the numerator, and this x moves to the denominator, and we can switch the exponent from negative 3 to positive 3. One more example of this, x to a power of negative 2 becomes x squared when we switch it from numerator to denominator, and y to the negative 4 in the denominator becomes y to positive 4 in the numerator. So when you have a negative exponent, you move that term to the opposite side of the fraction line, and then you make the exponent positive. Let's have you do a few practice questions. Rearrange each so all exponents are positive. Question number 1, 4 to the negative 3. Question number 2, 5x to the negative 2. And question number 3, x to the negative 3, y to the 4th, z to the negative 2, divided by v to the negative 5th times w cubed. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we're given 4 to the negative 3. That's the same as dividing it by 1. Anything divided by 1 is just itself. So this makes it a bit easier to see that step number 1, move the term with a negative exponent to the opposite side of the fraction line. So we move 4 to the negative 3 from the numerator to the denominator. And that allows us to step 2, make the exponent positive. 1 over 4 cubed is equal to 1 over 64. So that is the answer to question number 1, 1 over 64. Question number 2, we are given 5 times x to the negative 2. That is the same as 5x to the negative 2 over 1. Step 1, move the term with a negative exponent, which in this case is just the x, to the opposite side of the fraction line. So we move that to the denominator, and we make the exponent negative 2 positive, giving us an answer of 5 over x squared. Then question number 3, we have multiple terms in the numerator and the denominator. So we'll first work with the numerator. Step 1, move each term with a negative exponent to the opposite side of the fraction line. And then we make the exponents positive. Step 2, so in our numerator, the terms with negative exponents are x and z. So we move x and z to the opposite side of the fraction line and make those exponents positive. And then we have in the denominator v with a negative exponent of -5. So we move that up to the numerator. And that gives us a final answer of v to the 5th times y to the 4th divided by w to a power of 3, x to a power of 3, z to a power of 2.